Thank you. All right, so let's take about 4 minutes here, and that way we can kind of coordinate with our groups and get ready to present. And I think we'll just go top to bottom on the list here, which means that my group is first.
Can you tell us how many groups there are so we know kind of how much time we've got?
That's what I'm looking at right now.
Okay.
And Joe, so this is Natasha. So do
Hey,
you
Natasha.
want for me or Marty to present the Google Slides, because whenever we try to copy it, it doesn't have the same format. So I would have to share the one that I made originally.
Yeah, totally fine. Totally fine.
Okay. So do I share my screen now?
Give me just a second because I want to just see what time frame we have for everybody here.
Okay.
So I've got activated carbon and absorption, which is us, which is middle school. I see Loggerhead Marine Life Center with French. Are you guys here?
Yeah.
Okay. Everglades Foundation with Casuto.
Yes, we're all here.
All right, did I miss anybody? Because that's the only middle school groups that I see here so far.
There's Earth Echo.
Earth Echo, there you are. So
Yeah,
4 groups, it
and
looks like.
no, actually, C to C, I was in the elementary group, but I did a lesson for 7th and 8th grade, so I asked to be moved over here.
C to C. There you are for Turner. Okay. So you will be second on the list here. So it looks like 5 groups. 1, 2, 3, 4, 5, 6. And Ice Age, River Fossils, Paleontology. Are you guys here?
Yep, we're here.
All right. Have I not called out a group? Okay. So it looks like 6 groups. We've got until noon, which is, we're going to say an hour and 15 minutes.
So 15.
So 75 minus 6. That will give each group about 12 and a half minutes.
It doesn't smell like outside?
No.
Like geosims?
And if you guys would like, I will give you like a 3-minute warning in the chat box for each group as we're going through. All right.
Would you be against making it 10 minutes, and that way we can have some time to question people? About
Yeah,
their
totally fine.
research?
Let's do 10.
Great idea. It looks like there's a question on the order again. Enid's asking, was Loggerhead second on that list?
So we've got activated carbon and absorption first. C to C will be second. Loggerhead is third. Everglades Foundation will be fourth. Trying to go real slow. Ice Age River Fossils Paleontology will be fifth, and then Earth Echo will be sixth. Okay. All right. So I think we're ready to get started here. So Natasha, if you want to go ahead and share your screen and get our PowerPoint up.
Can you all see it?
Yes.
Or not yet? Yeah? Okay, cool. Thank you. Trying to see if I can present. Okay, does it show as a presentation now?
Yes, it is.
Thank you. So Michelle, I don't know if you want to start this first slide.
Yeah, I'll go ahead and start. So hi, everyone. My name is Michelle. I'm the scientist for the Activated Carbon and Adsorption Lab. The teachers that I worked with were Natasha, Joe, and Vincent. There were 3 middle school teachers, and then Vincent is a high school teacher. So I was super lucky to be able to kind of convey my research and have them put it into their lesson plans. So bear with me, I'm gonna fly through a lot of this so that you can hear the lesson information more so than the focus and goals. So if we wanna go and start with the about us. So I'm a 4th year PhD candidate. I work in environmental engineering, but my background is in both chemistry and biology specifically. I've added my email as well as my Twitter handle. So go ahead if you have any questions or you want to learn more about what I do as far as water and air filtration goes, you can always email me and I'd love to Zoom with you all. I'll let the other teachers go ahead and introduce themselves as well.
Okay,
All right,
again.
I'll go next.
Oh, I'm so
Okay.
sorry. You go ahead, Joe.
No, you're good. You're good. My name's Joe. I'm a 6th grade earth space science teacher at Horizon Academy in Marion Oaks, and I am from the Marion County School District.
Vince Newman here. You hear me?
Yes, we can.
Okay. High school teacher, Hollywood, Florida, one with the beach. MacArthur High School, formerly a dairy farm. I teach agri-science foundations, introduction to horticulture, landscape management, also aquaculture.
Go ahead, Natasha.
So hi, everybody. My name is Natasha Galindo Lopez, and I'm an 8th grade science teacher. Originally, I was 7th grade, but then they bumped me up to 8th grade this year. So it's really nice to have my kids back to back. I'm also, well, this upcoming school year, I will be the ESOL compliance specialist for my school. And my Instagram is teacher.miss.g. So I kind of have it so that my students can come follow me. But yeah, feel free. It's a new IG, so the more followers, the better, right? But yeah, without further ado, I think Michelle is going to explain our focus and goals.
Awesome. Okay, so we'll go ahead and fly through these focus and goals. So the focus and goals for our lessons, the first one was that we wanted to be able to define to the students what pollution from the air and water perspective. Then from there, being able to compare and contrast what water filtration looks like from both a nature perspective as well as from an industry perspective from your local municipality. Through explaining all of these ideas, we wanted to provide the students with a basic understanding of what the components in their DIY water filter and how that would work. And then the last one being, we wanted them to understand how air filtration occurs and why it's necessary. And from all of these different focuses, the end goal is to create your own water and air filter. We've tacked on the air filter specifically, and you'll see why later. The learning objectives that we have, we wanted to have them recognize the value of models in science, building a water column for different types of water solutions, and then explaining how to use the model to help scientists understand how the different interactions with the different Earth spheres occur. And then from there, being able to recognize how the different spheres correlate with each other and how they act independently of each other. Then the last 2 objectives we have on the next slide are just differentiating the different biospheres, cryosphere, atmosphere, and hydrosphere. And then from there, being able to explain and explain through example, the different interactions. So these are just the different learning objectives we have. And then I believe either Marty or Joe will go ahead and talk about the standards.
Yeah, I could talk about it. I'm Marty, and what we did, because we have a 7th grade, two 8th grade teachers and a 6th grade teacher, we're going to run kind of different standards because of the grade levels. So as you can see, without just reading, because I hate PDs in which they just read what you can read already, but those are the standards that for the 7th and 6th grade. And I believe there was some 8th grade, and there's also some other standards as well, of the prior knowledge that the students would need as they do the activity. Next slide. And vocabulary, and there's more vocabulary than just this, but what I did, you'll see later on, or not quite finished yet, but I also had vocabulary like solution, solubility, pH. So there's going to be more as we fine tune each lab to fit our various grades. We have a couple of essential questions that we're going to use to start the conversation of why water needs to be filtered or also treated. And those are the materials that we had. We're going to use hopefully common things like a Coke bottle or a funnel, or it could actually be any kind of bottle, plastic bottle. Various materials that will be used to help filter the various types of wastewaters we're going to have. So again, this would be available, so I don't want to take 10 minutes to run through things that you can read on your own. Again, we're going to make different wastewater samples for the students to purify or to treat. And those are just the recipes. And those are the accommodations, okay? And if you have ELL students, the dictionaries, extra time, as we all do anyhow in our classes. And again, bell ringers to start introducing the topic, to get the students thinking about the topics ahead of time. And this is my, okay, so what I do, because I teach 3 different, thank you, Joe. Because I teach 3 different levels of science, I'm going to take one specific lab I've been working on or instructions and change it to fit the 3 levels. So for my comprehensive science regulars, I'm going to actually be giving them the instructions of what to do, how much material, and so on. Whereas my advanced students, they're going to have to do the same thing, but also have a cost analysis. And then for my honors physical sciences, are going to be open-ended. They're going to have to decide what they're going to do and how they're going to do it. So because we have about 3 minutes left, I want to make sure we get to Natasha's.
Hi, everybody. So for my school, I thought that it would be best to have like a science night, because we're always trying to find ways to build those family student relationships and the teacher relationships as well. So, and then also, and I can't speak for other schools, but for my school, administrators love a rotational model. So for this science night, it would be on Earth Day. And in this rotational model, it could be held in either like a library, a gym, so a large space, or in different classrooms. The Photoshop file to maybe if you want to use this and just put your school and to put like maybe the time or the activities is you can find it in our file or in our folder, so you can edit it for your school. And so the first rotation would be to answer one of the essential questions through these posted easel pads that I love to use in my classroom. The second rotation would have a video with an interaction activity. And then the third rotation would have an air filtration model, which I thought would be super cool for the students to see. So the teacher would model this and show the kids how activated carbon or activated charcoal can purify the air. And then the last, once all the groups are together, they would make their DIY water filter. And then these are the resources. You can access the links by just clicking on them. There are like several YouTube videos showing how to do the experiments. So thank you so much, guys. I appreciate it.
Awesome. All right. Thank you, guys. Does anybody have any questions about this presentation before we move on to the next one? Okay, doesn't sound like it. So we're going to go ahead and move on to C2C. We've got a lesson plan developed for middle school here for C2C.
Okay, can everyone hear me?
Yes.
Yes.
Okay, let me pull up my share. Okay, let me get this out of the way. Hang on a second. Can you still hear me and see? Are you still able to see?
Sharing hasn't popped on yet.
Oh,
I can't see your screen, but I can hear you.
okay, let me try a new share. Of course. Okay, guys. It kicked me out, so I'm back. Are you able to hear me at least?
Yes.
Yes.
Okay. Now are you able to see taxonomy?
Yes.
Okay, good. So let me start from the beginning. Good. Okay. So my name is Marino Nardelli. I teach at Johnson Middle School in Brevard County. I teach 7th grade gifted science and science research. And I was in an elementary group because I teach 7th grade and it was kind of close to the elementary. And so I asked to be up here with you guys to teach a little bit more middle school. I immediately wanted to do something with taxonomy to lead into our marine lab trip. We do this every other year down to Key Largo in March. So I immediately wanted to have something for that because we always teach the taxonomy. So here we go. Okay, my focus is taxonomy of marine invertebrates. Down in Marine Lab, we do many classes where we have to identify marine invertebrates and identify their phylum, mollusca and cnidaria, and we actually go out to the reefs and go searching for some of those critters. We go to the mangroves also and search for many of the animals in that area too. So my materials. Starting off, I like to go really inexpensive, and Bill Turner from C2C was my scientist. So he suggested this a little bit different, but get some Minecraft travel card games. So what we're actually doing with the kids, since they understand, 99% of kids understand Minecraft, is to have them sort them. So they'll sort them any way they want, and they'll tell the entire group how they sorted them. And then I'll have them a second time sort the Minecraft cards, and they'll understand that they can sort them by color, by body part, or whatever the case may be. Then we'll go into animal flashcards. Actually, let me just tell you my materials, and I'll tell you a little bit more in the lesson. And these are preschool ones, and the reason I picked them is because they were very inexpensive. And various dried animals, which Bill said he can actually send me. And a PowerPoint, which I'll show a little bit towards the end. So my objectives. I want to show the relationship between organisms, such as symbiosis, producers and consumers and decomposers, limiting factors in the ecosystem, especially in the coral reefs and the mangroves of Florida. Now my standards, I'm just going to kind of throw them up here real quick, but we can always get the empirical evidence in there: producers and consumers, mutualism, symbiosis. And then I come up into some of the higher standards, such as domains and kingdoms, which are not actually taught in 7th and 8th grade, but we like to, at my school, send them with that knowledge when they take 9th grade biology. So you can see my vocabulary, many of things I'm sure you've heard about: food web, food chain, habitat, abiotic and biotic factors. A lot of that will be talked about down in Marine Lab. So day one, this is a 3-day lesson. This is where the Minecraft sort comes in. Told you a little bit about that. They're going to sort the cards according to however they want to sort them. Then we get into the animal card sort. This will be a little bit more familiar because they'll be having some land animals, sea animals, and such. And then I'm going to have them in their groups create a group such as this with their animals. Now, they might not have actual animal classifications as fish, birds, and amphibians, but as long as they have some type of grouping. Day 2, of course, where we review what we did the day before. I'm going to give them those dried animals, and they'll consist, Bill said he can get me some sea stars, other mollusks, all kinds of things. They'll actually have hands-on where they're going to sort them. And they'll probably sort many of them by bumpy, or, the sea stars by the arms. And then I'm going to have Bill actually come on. He's in Tallahassee, so I'm not going to have him drive down to Melbourne for a couple days, but he'll come on with actual sea stars and urchins and things and talk a little bit about how they hide, how they eat, and different things. Day 3 reviewing, and then I have this PowerPoint. I'll show you a little bit about the discussion of the basics of taxonomy. And the last slide, I'm going to pull up right here, just a moment. It's actually here, where I'm going to give them just this last slide where they can drag and drop the animals into vertebrates and invertebrates. So if you see, I can grab, is it going to work? No, of course not. It's not going to work right now. But in the slide, you can actually drag the mollusk to invertebrates and the fish to vertebrates and so on and so forth. So I think this is going to be a really good lesson to give them that foundation to take down to Marine Lab. In the past, we've taken 2 weeks to go over some of these things, and a lot of it was note-taking and worksheets, but I think this can be done in 3 days to give them that focus and not take away too much of other teaching. Any questions? Is anyone still there?
Yes,
Yeah, we're all still here.
Okay. It's that awkward silence, and we
Yeah.
wonder if, yeah.
So Stephanie did put in the chat box, love how you elevated a previous lesson.
Okay, let me pull up the chat. Okay.
Any
Any other
I had a question
verbal?
about, yeah,
Go ahead.
about the card games. I was just wondering about if you had an idea about how many cards you would need. Like, are you envisioning putting them in groups, or are you
Yes. Well,
having them work independently?
I tend to have say 20 to 25 per class. So I would put them in, say, 5 or 6 groups and give them 15, 20 cards. The cards are not too expensive. So if they, Bill said he used to do a taxonomy where he would give them cars, little matchbox cars, and they would match them up by things like that. For me, that wouldn't work because by the end of the day, I would have half the amount of cars. So, with Minecraft, I'm sure they're gonna take the cards and stuff, but that's not too expensive. I always have to look to see what is not so interesting for them, so they don't want to take.
All right, thank you.
Coastal communities can do shells. Yes. In C2C, make sure you go there to see his stuff. He can send you lots of ocean things and shells and different things like that. So if you're doing an ecology lesson, he can just flat out send it to you, and if you're kind of close to Tallahassee, he can come to you. I'm about 6 to 7 hours away, so I'm not even going to attempt to have him come. Let me get off of.
All right. Well, thank you, Marino. That was excellent. I'm not very familiar with taxonomy. It's not usually in my scope of lessons. So it's really cool to kind of see something that's in a different grade level and how those things are presented as well.
Thank you.
Next up, we've got Loggerhead.
All right, so I'm gonna go ahead and share my screen. Okay. All right. So with Loggerhead, just a little bit about Loggerhead. I don't know if Loggerhead wants to come in and explain a little bit about what they are, but in summary, they are a aquatic marine like kind of a vet place that also does a lot of outreach. And what they've done is they've provided with us an elementary kind of lesson where they look at trash and how trash ends up in the ocean. And they talk a little bit about that in an elementary kind of context. And what we did in this PD is we adapted it to the middle school setting by increasing the rigor, increasing the vocabulary, and also incorporating some of the math skills. And that's kind of what I bring into the team. So just quickly about us, I'm Evan. I've been teaching for 2 years. I got my degree in physics from UF. So I'm really happy to be a part of this group and to bring science into the classroom. And I'll let my other presenters introduce themselves.
Okay, my name is Debbie Villar, and I'm an IB coordinator in Orange County with grades 6 through 8. And I'm working out of 2 schools, 2 Title I schools.
Hi, my name is Ina Hernandez. It's my 4th year teaching at a public school, but it is my 1st year teaching at Hillsborough County. I'm going to be teaching middle school this year for the first time. I was teaching high school before, but I'm going to be teaching middle grades comprehensive science.
Hi, I am Wendy Kearns. I am out of Central Florida. I have taught at the elementary school level from science lab to 4th and 5th grade classes for the last 13 years. And this next year, I'll be moving to 8th grade science at one of our local middle schools.
Hi guys, I'll pop in really quick. I'm hiding behind the turtle icon. I'm Lindsay. I'm the Assistant Education Manager here at Loggerhead Marine Life Center. I'm filling in today for Emily, who is working with the group on this project. Emily's actually off on Fridays. So Loggerhead Marine Life Center, we are a sea turtle hospital and research facility located in Juno Beach, Florida. We do work a lot with trash, of course. We're a hospital. We do see a lot of marine debris impacts in our sea turtles. So we have a robust curriculum for elementary school, but we really enjoyed working with the team to sort of bring those efforts up to middle school, which we really needed here. So thank you guys so much.
Okay, so to explain a bit about what our idea in this PD was to kind of break it apart into 2 lessons. On the first day, it was going to be more of a science lesson where the kids were going to be kind of introduced to the topic of how plastic is polluting the environment. They're going to look at and compare dates from the past with dates in the future that it's going to take things to erode. And these are a few of the objectives that we had in mind for the first day. Most of them are science related, and they have mostly circle around environmental impacts and that sort of thing. So these are the standards that we had in mind when we were creating this lesson. And this is a bit about the vocabulary that they're going to need to kind of approach this lesson, and a few of the standards that we're hoping that they will already know and bring in to the lesson. The essential questions that we're going to be asking the students are like, how does products that we use affect the ocean? How does it get into the ocean? And then also about the ability for an item to degrade and how that affects its likelihood of being found in the environment. So
I think Evan froze, so let me go ahead and pick up here. On day one, we're going to start with a Padlet activity to access their prior knowledge and use the prompt causes of water pollution. Then we have a video introduction. It's a group of 3 videos that kind of give them a background of what marine debris is and how it's collecting on our coasts.
yeah, hello.
You back, Evan? I was going through the day one as far as the videos, and that's as far as I got.
Okay, am I sharing my screen still?
No.
Oh, sorry. Definitely talking to myself. Give me a second here to pull it back up. Okay. All right, can everyone see my screen?
Yes. We're back on the previous slide about day one.
All right.
That one right there. So we were on the video introductions. There are 3 videos that give them a basic background of marine debris, where it's collecting, what it looks like. So they have visuals to put with the vocabulary. Then we have a gallery walk and then an exit ticket with some homework where they actually look at the plastics in their home by completing a worksheet to see what kind of plastics they have in their house and how much of it there really is. So let's take a look at the gallery walk. The gallery walk is going to have these pictures around the classroom, and the instructions for the students, the directions are listed on each of the posters that you would print out and put around your room. Then the students have a worksheet where they will actually put these put pieces of plastic debris on a timeline and match them up with when they think it happened in our history. So each of these items shows picture representations of events and times in the past, from 600 years ago to only 20 years ago. Then they are going to take the worksheet that has 6 different plastic items, and they're going to go through and try and decide which item matches up with that time from the past. So which item it takes 600 years to degrade, which one only takes 20 years, and all the ones in between. So this matches up some of the Florida and nation history with those particular items. And so they'll spend about 5 minutes at each one looking at the pictures, discussing with their groups, and then trying to decide where they think that plastic would be if it were still in our past. So here's the timeline. We provided it in color and in black and white. You have fishing line, you have the holder for a 6-pack of soda, water bottles, a plastic Ziploc bag, a diaper, and then a tin can. And so they have to go through and decide which event in history would these have gone in if they were, if, for example, if fishing line took 600 years to degrade, then they would put it with the event from 600 years ago.
Okay, so seeing as how we are time, I just quickly want to run through my idea for the second day, and this can be seen as kind of like a parallel lesson that doesn't necessarily have to follow immediately, but can be seen as more of an independent math oriented kind of a lesson. How I structured this is I found some standards from the 6th and the 7th grade, and what I did was I first introduced the topic, I included some videos, and we can kind of just So this is just kind of an example of what the lesson would look like. There are a couple of short videos that talk about this as a problem, and they're only like 2 minutes long. So it's short enough to keep the kids engaged, but not, super duper long so that you can't kind of move on and work on the next topic. And this is all kind of getting us to looking at how scientists are able to track how trash ends up in our marine sources. Let's see if I can fast forward through some of these. In the middle of the lesson, there's going to be like a comprehension check that's just kind of looking at if they're understanding the topic. And then it's going to lead to looking at how we can use information that's publicly available to make a conclusion about how trash is changing over time, is what items are the most common. So that's kind of like what I have here. It's just a table that's got some information, and the students are going to use that information to find the total for 5 years, the median and the mean, which are a few of the 6th grade standards. Then they're going to answer some questions. They're going to answer some more math questions, So I just kind of thought I would put some extra math questions just in that way. Students in the 7th or 8th grade would still have some challenging problems that go beyond just the 6th grade standards. And then as extension activities, I also included these. These could be like homework activities or things that they take home, or can be, extra questions for early finishers. And I think that's it for the presentation. So thank you so much. Sorry if I went over time.
I think we had a minute or so to spare for you there. I was really interested in seeing how you're going to tie the math standards in.
Okay.
My first year teaching, I was a math teacher on top of being a science teacher. So anything that kind of that goes across those subject lines is really cool, and I really enjoy seeing that. So I was very interested in seeing how you're going to blend those two things together. I think we've got about 30 seconds to 45 seconds here if anybody has any questions for Loggerhead. Trying to modify for math in 2 grades is a lot. Yeah, it definitely can be. It definitely can be.
Yeah. And I just want to say that I had a lot of fun making these lessons and trying to find these problems. And I really love incorporating these like scientific problems and getting my students to kind of relate the topics in math with kind of what they're seeing in the world. And speaking on how they're relating to the standards, a few of the standards are looking at proportions and percents. So I was asking the students, like, what percentage of the trash is this versus that, which are very like foundational standards that kind of lead into like pre-algebra, things like that. So yeah.
Very cool. Very cool.
And also let me tell you, if you guys want the download for the PDFs for the gallery walk and the worksheets, let me know.
Absolutely.
Enid, can you all stick those in the folder as well for everybody to have access to? That'd be a great place.
Yes, they are.
Oh, perfect. Okay, thank you.
Hey everyone, we're also going to plan to have this up on our educator portal on marinelife.org once we sort of put it formalized onto our template and stuff. So I can share that out with Stephanie after the fact and we can get it out to everyone. But great job, you guys. It was awesome. Thank you so much for working to connect our marine science with middle schoolers. It's really important to us. So thank you.
Awesome. Great job, guys. All right, let's move on to the Everglades Foundation. You guys are up next.
Great. If I could get confirmation with a thumbs up that you can see the screen, then I'll go ahead and get started. Perfect. Thanks, Stephanie. All right. Hi, everybody. Good morning. My name is Bianca. I am going to be representing my group today. We are the Everglades Foundation Lab Group. Within my group, we have Erin McGee from Broward County, Lachlan Shaw from Leon County, Alka Singh and Asa Mahoney, both from Orange County. We are obviously a middle school cohort, although Alka does teach high school. So that's been kind of interesting working with a little bit of a variety of our group here. My group is definitely available to unmute themselves or add any sort of feedback or answer any of your comments or questions in the chat. So because we did things a little bit differently, and I will show you what that means throughout the PowerPoint, but I wanted to start off by showing what our goals for this Hydrosphere PD week were. So I wanted to introduce my lab group to the importance and the value of the Everglades ecosystem, explain how the Everglades is defined and connected by water. Because my program already offers standards aligned lessons, my lab group actually took a look at some of those Hydrosphere lessons and then provided their own feedback and accommodations that they would make for their classroom, which I'll share with you. And then we also worked collaboratively to tie in that classroom learning and take it a step further by creating by brainstorming a civic action plan for them to work with their students. And I'll share a little bit more about that as well. So one of the first things I wanted to share with everybody that's part of this PD week is some of the answers that I received. So I asked the group, what interesting or new information did you learn? And why should we teach and learn about the Everglades ecosystem? So on the screen, you'll see a couple answers pop up here. Teachers and students should know the importance of clean, fresh water. Absolutely, that applies to all Floridians as well. It's important to teach about the Everglades because it is where 9 million Floridians get their drinking water from, which obviously impacts our students. And I thought this answer was particularly interesting because while the Everglades watershed spans Central and South Florida, we think that all Floridians should know about the issues that the Everglades faces and why it's so important to protect it, simply because we are all Floridians and we should all protect our resources that we have in our state here. So if there's anything that any of you would like to share about anything you learned from my presentation on the Everglades, please feel free to write it in the chat, but that's totally just an extra thing to do. So the Heart of a Watershed is one of the lessons that we showcased within the group. In this lesson here, teachers and students learn about changes to the Everglades watershed. And after they learn about both the historic and altered Everglades, they use materials like Play-Doh and page markers and toothpicks to create models, one of the historic Everglades and the other of the altered model. These models should represent the way the water actually flows within both the historic and altered Everglades watershed. And so on the screen here, you have a couple pictures of what those student-built models look like. The original assessment to this lesson is for students to draw diagrams of both of the models and then label the components. Students are also supposed to write a summary paragraph that compares both the historic and altered Everglades watershed. So a couple team members on my lab provided their teacher modifications to this lesson, in particular the assessment. So some of the suggestions for this lesson were to identify middle school standards. It is a high school lesson, and because I'm working with middle school teachers, of course, you need to bring those back to the classroom. One teacher recommended translating it into Spanish to service a larger student audience, which I really like, and our program is working to do that. Another teacher has an idea to create a math activity about ratios. So within that lesson, students learn that for every dollar you invest in Everglades restoration, you get $4 back in economic benefits. So I thought it was neat to bring back that, that economic study to the classroom and then turn it into a math activity. Another teacher recommended editing the lesson plan PowerPoint where you leave certain spaces blank and then the students have to fill in that space with the answer or the vocabulary word as a comprehension check. And I know that that's something that a lot of teachers like to do. And then Lachlan in particular, she provided an alternative to the assessment by providing a choice board project. So for those of you who aren't familiar with choice boards, it's when you give a variety of options as an assessment. So Lachlan recommended that instead of having to write those summary paragraphs, students could design a comic strip or write a song, make a poster, create a play, get a little bit more creative with assessing the students to understand that they can comprehend the changes to the watershed and also understand what the social, economic, and political consequences are for that. And we are getting some good feedback in the chat, so thanks everybody who's participating there. The other lesson that my group decided to provide feedback on is on a lesson called Everglades Dilemmas. In this lesson, students are presented different water dilemmas that affect the Everglades. There is an example of one on the screen. I will read just the dilemma part for you, and you can read some of the suggested solutions. So you and a friend are hiking in Everglades National Park, and you see someone dumping a 55-gallon drum of a dark liquid into the water next to the trail. What should you do? So in this lesson, students work together and they review the options to figuring out these Everglades dilemmas. They have to work collaboratively, and they also have to take a social, political, or economic standpoint and justify their reasonings for selecting their solution to the Everglades dilemma. The original assessment for this, after you have your students pick their solutions to the dilemmas, is again an explanatory essay that describes 2 different dilemmas that you might face daily and discuss how the decisions you make daily can impact the Everglades and its watershed and habitats. So that's the original assessment. And then some of the feedback we got for this lesson would be to develop additional Everglades dilemmas. Here's a screenshot of another one from the lesson already provided. But as a teacher or as students, you can definitely create your own water dilemmas. There's plenty of those to choose from and to identify. Alternatively, a philosophical chairs debate too. Yeah, absolutely. This lesson can also be translated into Spanish. Erin in particular mentioned that she would replace the essay with a poster project to make it a little bit more creative for students to have to identify those social, economic, and political decisions. Alka in particular recommended using Nearpod with this lesson to bring in components of virtual reality, simulations, and some fun, engaging quizzes. Alka also recommended using a 4 corners activity where students have to go into the 4 corners of the classroom and justify their decisions that they chose using debate. And another suggestion that I really liked for this one was following up the lesson by reaching out to an elected official and writing to them what these dilemmas mean for them, and students sharing their perspective on why it's important to protect the Everglades. So the civic action piece to this extension is really based on research that shows us that when you engage young people in actively addressing local issues, they're more likely to feel like it's something that they can relate to and actually make a difference with. So my foundation partners with Earth Force for this. I won't bog you down with all of the details of it, but Earth Force is an incredible partner of ours that provides a 6-step community action and problem-solving process. So our issue that we selected was water quality and quantity, specifically asking why do we have harmful blue-green algae blooms in the Everglades? Some of the root causes for that are excess nutrients from fertilizers, septic tanks, pet waste, and other sources of pollution. You may or may not know that in 2013, the Department of Environmental Protection mandated that all jurisdictions in Florida had to approve and adopt the state of Florida model fertilizer ordinance. Essentially, this ordinance says that local governments can deem it unlawful to utilize any sort of fertilizer that contains nitrogen or phosphorus within the rainy season, which is now in the summertime. On the screen, you do have some locations that already have this ordinance in place. I have a couple options down in South Florida and Central Florida, but again, it is available in other places throughout our state. So the teachers went through the 6 steps as if they were working with their students on it. So teachers recommended doing some water quality monitoring, some news media research, and speaking with local institutions to gather that background information or gather your community inventory. For step 3, policy and community practice research, we kind of went over who's affected by dirty water, right, or algae blooms, what's already in place, who can students partner with to learn a little bit more about this, and what needs to be changed. I want to share that we think that more cities and counties should adopt this ordinance in the summertime, at least at the minimum, to make a difference. Can also explore current best practice managements that exist and making sure that the average Floridian knows not to dump any sort of household cleaning product or oil or anything else that is a pollutant down the drain, because it ultimately will end up in our bodies of water. Step 4 was to identify some goals and strategies. So here, the goals that the teachers identified were to establish accessible water quality monitoring and data analysis, creating an education and awareness campaign to help inform people, and meeting with elected officials, again, to share why students think that this is so important. We want our students to work collaboratively, be thoughtful, know how to communicate, have that professional etiquette. We identified some limitations and barriers, and because we are running out of time, I do want to say that the last step is not only for students to reflect on what they learned, so identifying why they did this, what was their purpose, what worked well, what were the strengths, what were areas of improvement. And also celebration is really important too. We want to make sure that our students are recognized for their efforts. So we can celebrate our students by allowing them to share what they've learned within their school community or larger community, sharing that information with elected officials, school administration, and receiving recognition from anybody who's willing to thank students for being part of this civic action. So this is the last slide here. I do see a couple of comments in the chat. I know this is a little bit different than what everybody else has been working on, but it's been a wonderful opportunity to work with my group. And if there's any questions, please put them in the chat or unmute yourself. Joe, please let us know how much time we have left for that, if any.
Yeah, we've got about a minute here that we can take some questions if we need them.
Great. I could collab with civics. Yeah, absolutely. So if anybody works with civics, these are some good, this could be some inspiration for there. Everglades Dilemmas is a wonderful lesson. I definitely recommend teachers checking that one out. Stephanie plugged the Everglades Foundation resources. Thank you. We have 8 PhD scientists on staff that do provide science to our water management districts. And getting your students involved in the community. Thanks, everybody. Appreciate it.
All right. So next up, we have Ice Age River Fossils Paleontology Lab.
Awesome. I'm going to share my screen real quick and we will get started. I am just going to introduce everyone real quick. Can everyone see the screen and hear me?
Yeah.
Awesome.
Yes.
I was the graduate research scientist that helped out our group of teachers, and I'm just going to introduce them real quick. We had Joe, Bethany, and Brooke, who all actually had a wide range of grades, 5th through 9th. So they actually chose to do 3 separate lessons. So ours is going to look a little different than everyone else's, but they're all super awesome and creative, and I'm really excited for you guys to see them. So we're going to dive right in with Bethany.
Hi, everybody. My name is Bethany, obviously. So I'm a little bit different in this group. I actually teach 5th grade, but I teach at Orlando Science Elementary School, and a lot of our students are advanced. So even though I teach 5th grade, a lot of times we end up running into 6th grade and even 7th grade standards. So I do math and science. I did put 5th grade standards in since that's mostly what I focus on, but just kind of a background of why I'm in the middle school group. Like Mackenzie said, we all did something a little bit different to fit our standards, but it's very similar. So in the Ice Age river fossils, as Mackenzie was sharing out what she does for her research, one thing kind of stuck out to all of us, I would say, and the best way that I can describe it is she uses teeth from animals that lived in Florida from the Ice Age, and they do a multi-proxy analysis that goes through learning about how, like what they ate, the climate of the time, and all that good stuff. So the idea for my lesson is to connect with my interdependence unit where students are learning about ecosystems and food chain and stuff like that, and actually use the multi-proxy analysis themselves. And so there's 3 parts to that Mackenzie uses. 2 of them are a physical type analysis where they actually look at the teeth and see, are the teeth really flattened? Do they have scratches on them? Do they still have big, deep, like hills and valleys in them? Because that tells researchers and scientists exactly what they ate, depending on how the wear on the teeth is. And then there's also the stable isotope analysis, which is that chemical analysis, and it gives a little bit more detail to exactly like, okay, what was the climate like? What specifically did they eat, etc. So I'm going to have the students engage in doing that. and they're going to use 3D printed teeth from the time, and basically just go through the steps of organizing them on the charts. And so I threw in some of the vocabulary there, as you can see. So some of the things that we're going to be talking about. So they'll first start and learn, like, what is a fossil? Make sure we're all on the same page. That fossils aren't just dinosaurs and they don't just look cool, like they can actually give us information. And then all of the other stuff that goes along with it. I'm actually going to go to my next slide, Mackenzie, because that has some pictures. Okay. So the chart is the chart that I want the students to ultimately create. And that goes along with exactly what Mackenzie does with her research of categorizing the animals into what they eat based on looking at the teeth. And on the right side, I have a 3D example of what the teeth look like. And then I have these little logos, the Sketchfab and the Morphosource, just to show that's where these 3D teeth are coming from. So you can use those sources to find any kind of 3D modeling that's already been made that's accurate. So Mackenzie was sharing with us that the University of Florida has their own, in a sense, database within these websites. So then you know that if you're pulling a replica of a fossil, a 3D model of a fossil, that it's actually a correct replica. It's not just somebody in their garage kind of saying, oh, this looks cool, and throwing it together. So you can make sure that those are actually correct replicas, and just use, if you have access to a 3D printer, that's what we're going to do. My school has a 3D printer, so I'll just load those on there and print them. Mackenzie also did share that there's usually a lot of programs to help with 3D printing, like even local libraries might have 3D printers if your school doesn't have one, or if you're close to a university that might let you 3D print as well. So there's some options if your school doesn't have a 3D printer. Anyway, so we're going to use those, and so the kids can actually physically hold them and touch them and make this chart. And we'll relate it back to what we've learned. I'm seeing this as the end of the interdependence unit, so then they can relate the stuff that they've already learned to this extension. And kind of, I have a lot of questions planned. This actually is a 3-day lesson, but so there's like a lot of parts to it. But in short, that's what my lesson is. And I'll let the other two go for sake of time.
Awesome. So next we have Joe.
Hello. So I'm actually doing a 6-month-long project with 2 different lessons that I created. One, we are going to create a mold using teeth. I made some salt dough teeth, like a little jaw, last night. And I have my leaves, and we're going to analyze the browser to grazer spectrum with different leaves, shrubs, and grass. So we are going to make teeth of the tapir, the horse, and the mastodon. As I have here, we have our tapir, which is the black teeth, and then our mastodon, and then our horse. And we are going to, over time, we are going to take our leaf, put it in our jaw, and over time, we are going to see how the teeth will change, monitoring by the photos and the change and the mass. We're going to be measuring the mass on a scale and recording the changes each day over a 6-month time period to understand our animal classification. So we have our browser or grazer to browser spectrum here in understanding. And Mackenzie was amazing with bringing this into our group and helping us do with that more of that dichotomous key and animal classification, but using teeth. And it's also going to be an engineering project. I did not include that standard, but this is what we're going to do. And then I have a second lesson, which I built a small one, but using just Tupperware, where we're going to be measuring the salinity and pH of the Peace River conditions, and then the Gulf Coast with salt water. So we're going to be doing this over 6 months, putting our, again, this is just salt dough, putting our fossils in here and creating the conditions by moving it around. Sorry, I didn't want to tilt it so that you could see it because I had spilled it. And we are going to make it like the actual conditions so that they're able to see how it changes these fossils over time. Now, this is going to be telling the difference between our freshwater and saltwater fossils, analyzing the difference in salinity amounts, and analyzing the change of the fossils over 6-month time in these different conditions. So using that chemistry and measuring the pH and the salinity, and also how the change of these fossils can happen over time. We actually are going to create fossils using air dried clay, and then also 3D printed fossils. So those are just 2. I came up with many, many more, and this brought in such an amazing idea factor, especially working with those index fossils and understanding how things can change. So my projects are very long. So
I do want to mention for Joe's real quick before we move on that for simulating the conditions of the Peace River here in Florida, she does actually have a river table that she will be using. So we're looking forward to getting videos of that as well.
I created a full stream table that I built, and I'm just going to be reusing it again, but also for the ocean, I'm just going to keep it a little bit more simple, but making sure that I get that. Okay, done. Thank you.
Awesome. You're doing great. And finally, we have Brooke. Go ahead, Brooke.
All right, I'll try to go quickly because I saw that we have just a minute. I teach 6th grade and 8th grade at a Title I middle school here in Sarasota. My lesson does focus more towards 6th grade, but it can be altered to fit with your 8th graders. What it's going to be is my students are going to get either pictures of teeth or use the 3D examples. They're going to have to analyze the teeth. I'm not telling them the names of the animals at all, and they're going to have to classify them as either a browser, a grazer, or a mixed feeder. Once they do that, we're going to categorize them and give them names. Once they do that, each group is going to get one specific fossil to focus on. They're going to research the animal, figure out when it was alive, and I'm also giving them either the percentage of carbon left over in the fossil, or they're going to get how old the fossil is. And there's actually a carbon dating calculator that they're going to use online, where they input the information and get the missing piece to put in. And essentially what they're creating is like a little file on their animal, which they're going to share with the class. Yeah, thank you. So each group's going to be making one of the posters about their specific animal, and as scientists, they're going to come back together and share their findings with the other students in the classroom, where they're each going to graph the information. Once we've got all the information, all the animals classified, what they're going to do is actually put them in order of the oldest to the youngest. We can also have a little chart in our classroom to reference for law of superposition as well, which can be used throughout the unit. I feel like I moved quickly. If you have any questions, that's all of mine, a short, quick version of it.
And that's all we have, but if we have time, you guys, I can't open the chat, so I'll stop share and ask them any questions. They work super hard on this.
I just want to say these have all been awesome so far. I'm taking screenshots of things and just really amazed. You guys did great work, everybody.
Absolutely. All right, I don't want to rule the clock with an iron fist here, but we are running a little short on time, so we're going to move on to Earth Echo. Feel free to take over whenever you're ready.
Okay, I'm Amy. Can you guys see this screen? Do I need to do anything there?
I can see it. You're good.
Okay, so present. All right, so we're the last group and we represent Earth Echo. And so let's see. Okay, there we go. So in our group, I teach environmental science. We had Mary, who's a science coach from Miami. Chris is an environmental science 9th and 10th grade teacher. And then we had our Earth Echo amazing helpers, Jacqueline and Portia. So I just wanted to give you a little overview of Earth Echo. I put the mission statement up here. Basically, their goal, let's see if I can get this over here. Sorry. The mission is to build a global youth movement to protect and restore our ocean planet. So as we were thinking about our lesson, what we would do, we kind of tried to look at a bigger picture first. So we were looking at what is a watershed unit, like an overview of it. And we were thinking, what does a kid or a student or a class need to know in order to really be stewards for the water? So we thought the big key ideas were, what is a watershed? Where does water come from? How do we use water? How has our watershed changed over time with humans and nature? How healthy is the water, which is highlighted because that's the actual focus lesson that we'll present to y'all today. What actions can we make to protect our watershed? So if you see this link here, I'll click on it quickly. Kind of a brain dump that is going to be a working doc that's in the slide, but showing the different things. So if you look, each main category or big idea is then outlined below. So what is a watershed? And having the vocabulary in it, the activities that you could do, which would be ultimately linked with lessons. And I can see using some of y'all's lessons and putting them in there to the different categories. And then videos that also help engage the students. So that was kind of the overall unit situation. So what we're gonna look at today is how healthy is the water. So you'll see our lesson linked there. All right, so let me see if I can get back out of that. Maybe. Sorry, guys. How do I get out of it?
You might there, right there. Click on the Earth Echo Water Challenge PowerPoint up top there.
Where is it?
The first tab. The first tab.
I don't know. I've got a bar up here, so I can't see it. Let me get down there. Oh, there it is. Yeah. My chat was not up. Okay, so our focus lesson today, I'm going to turn it over to Chris, but it's the Earth Echo Water Challenge. And the Earth Echo Water Challenge is to try to get kids in and focused in an actual hands-on experience. So Chris, you can take it over.
Okay, and the learning goals and objectives that we came up with for this particular lesson, connecting students to water by monitoring a local water source. Explain the parameters of water quality and the chemical tests that scientists use to determine water quality. Perform simple water quality tests on a sample, then compare their data to other areas in the country or the world, perhaps. Conduct tests of water quality at a designated site and record their results, report data on monitor.org, which collects data input from all around the globe, which makes it really easy for these kids to collect samples from a local source and then compare those readings or that data to other data from around the world.
Right.
Learning standards, and again, we had a kind of mix of grade levels, so we included both middle school standards and, as you'll see on the next slide, high school standards. Some 9th grade standards thrown in there. Some of the resources, okay, you're good.
Okay, sorry.
No worries. Some of the resources and multidisciplinary connections that we added that may extend outside the parameters of this individual lesson, but could be beneficial in other lessons were obviously the Earth Echo, main site for the organization, as well as the site needed for this particular exercise, water calculator, which is a virtual kind of fun way where they can go home and get involved with mom and dad and see how many times they do laundry, see how many times they wash the dishes. Do we have a pool? Do we have pets? And realize that all those things interconnected affect the amount of water that's used on an individual household level. And then there are a couple other data collection and analysis and graphing links that we provided to include the Environmental Protection Agency water quality standards and some really neat other interactive sites that could be used as a part of this lesson and beyond. Materials, our go-to material were the water test kits from Earth Echo, which provide 50 opportunities to test water for the main problems: pH, dissolved oxygen, temperature, and turbidity. We provided a link where those kits could be ordered directly from Earth Echo, and then also a data collection booklet where data gleaned from those tests could be documented.
Okay, hello everyone. I'm Mary. I will be going over the lesson component. We did it in the 5 E's, where the first thing that students would do was watch a video from Earth Echo on the challenge. And the 2 ways that we decided to do the lab is, the first idea was to have one water source, and then all of the students would do the lab together, teacher guided. So after every test that they conduct, they'll be able to put their data on the board, and then we'll look at it to make sure to see if there's any outliers, and probably have the students retest before we go ahead and start putting the data into the monitoring tool. The second section would be where we give students water from different locations, and they'll be testing that over time, collecting the data, and then putting it on the Earth Echo Challenge website. If we have time, we'll show the video, but you can go down to the next slide. So I went ahead out to do the lab to see how quickly it could be done, because they said 15 minutes. It took me a little longer, but I think it would take the students a little longer. So make sure that this is like probably an entire class day to do the lab. So we'd give them background information on the lab activity, which would be called Water Quality Investigation, Earth Echo Water Challenge. So this is the map of the site canal that I went to get the water. So as you can see, the canal is C9, South Florida West Management District is the one that takes care of it. It's called Snake Creek Canal. It runs 26.7 miles. So the surrounding areas, the major highways, railroad crossing, they have tree-lined shorelines, landfill, it passes through, residential area. It also goes by the Dolphin Stadium. So if you've been down here, then you'll know exactly where this is running through. They have a boat jet ski ramp and a marine life for shoreline fishing. So I chose this because I always see a lot of people fishing. So I wanted to do that. And I did my draw of the water at the almost at the end of the Snake Creek Canal, because it runs through Miami-Dade County and Broward. The next slide. So that's me with my Earth Echo shirt. I was on my way out of the door, and the Earth Echo, the mailman dropped it off, so I decided to take it with. So this is the kit that the students would be using. It comes with everything in it for them to do the analysis. And with the video, they'll be able to see how to do it. I went ahead and used the Earth Echo data sheet, which they'll be using to input their data. And from there, when they're doing the lab, they'll have additional questions that they'll need to explain what each of the data points are and what we need to do if we need to fix anything, or what would they recommend. So that would be, and then after, we did the sample and now they have their own site they'll always collect data on, then they'll input that into the system. And that's it. That's it for me.
Chris, do you have anything to add?
No, I think it's been pretty well covered.
I think the only thing I would add is in the evaluate section, or even in the expand and elaborate, it's kind of getting more the graphing involved. And if you go to the monitorwater.org, you can look at sites around the world and click on them and look at your local source versus something in India or Africa or, different part of America. And for our evaluate, we had a comparison activity, your local site versus site around the world. And then we had a Kahoots kind of overall question about the whole project. And so
I do have one thing to add. I'm sorry.
Yeah.
Still going? No, I just wanted to mention that we considered, safety, being around the water, using these test kits, as well as differentiation, but thought that each individual teacher could apply those kind of things to their own school setting, but it was taken into consideration.
And
That's
if you
it.
do live around water, we also thought it could be fun to do this over time, have it an ongoing monitoring the water situation with seasons or after big rains to see if there were any changes. So I'll stop sharing. Any questions from the other groups? That's it then.
Was that our final group?
Yeah.
Excellent. Well, y'all did fabulous. I have to say, I am just blown away. I'm thinking that probably Brian and Bruce will be jealous that they missed all of your presentations, but fortunately they're recorded. Truly amazing. That's why I love this grade range in general. So I'm going to go ahead and post in the chat box the survey. And this survey is for teachers only. So scientists, you do not need to worry about clicking on that link and taking anything. For my scientists, I love you all. Thank you so much for everything, your dedication, your expertise, for taking time to share with this group for the week and partner with these teachers to collaborate and grow our next generation of environmental stewards. So super amazing. You guys are fantastic. And scientists, if you'd like to go at this time, you certainly can. But teachers, if you will please not leave until you've completed that survey, that would be super helpful for SEPs. So I'll stick around and hang out. Bethany, that's it. After you've completed the survey, you're free to go and enjoy the rest of your summer. Thanks, y'all. I can't type fast enough.
All right, I just finished. Thank you so much. Thank you, thank you.
Thank you. It's been fun.
Have a great summer.
Yeah, it's been awesome. Thank you so much.
Same to you all. Enjoy your summer. Take
Yeah,
one.
you as well.
Thank you. I finished it. Thank you so much. You're muted.
I was just saying it's been a pleasure. We're so happy that you enjoyed it and we're so happy that you were a part of it. Thank you.
Thank you. And I'm going to, I'm going to write a paragraph and I'm going to send you because I have to still receive my certificate. My name is not in there.
Oh, I can take care of that. Thank you for bringing that to my attention. I'll make a note.
So I will do that maybe by today or tomorrow.
Are you sure?
Yeah. Can I email? I just need to know the topics because I was not there. So what topics were there so I can write and I can specially go and look for them and then I can do that.
Okay, hold up 1 second here. I'm just going to go into the file and double check. 1 second. Let me just do a search. Yeah, you're in the certificate.
Hi, boss. Actually,
Yeah, do a control F search to find you because it's
fine. Okay.
And you'll find it. Yeah. I was gonna say I thought I double checked that and check that again.
Yeah, I know because I was looking and I saw some of my group's names. I said like maybe it's just our group, and then I said okay, I will ask her.
No, they weren't in any particular order. So they just were how the applications came over.
Yeah.
To me, I just popped them in there that way.
So
you're in there, just do a control F search.
Because I think yesterday I missed the first part of it.
You can find the recordings and go back and review that and send the requested information over to Brian or myself.
It is day wise, so I will know what day it was. So it is the third day, which I missed some part.
Yeah, so just look for Thursday.
Okay.
Thank you.
Thank you so much, Stephanie.
You got it. Take care.
Yeah, thank you. Thank you, Stephanie.
Thanks, Chris.
Appreciate everything.
Thank you so much. We really had a lot of fun with you all. I can't wait to do this back in a physical setting again, just because it brings everything to a whole new level. So we hope that you all will continue to participate with SAFs and engage with us because we really enjoy it. So thank you.
Definitely. And it was well presented and organized. Thank you.
Well, thank you. Thank you so much for that. Have a great day.